Okay. Hello everyone. My name is Dr. Nagaraju, working as assistant professor in the department of CSEA and ML in Institute of Aeronautical Engineering, Hyderabad. So today we are going to cover the first session of the concept, which is called as Introduction to Logic. In the earlier sessions, we have completely covered the various theoretical concepts of artificial intelligence, and we have seen theoretically how heuristic search techniques like how informed search techniques and uninformed search techniques are going to work, and how expert systems are going to work, and how different other AI algorithms and techniques are can be implemented. All those concepts we have seen. In today's session, we are going to cover a little bit about the programming. That's why our entire concentration during this session will be on the logic. So in this particular presentation, we are going to cover some of the introduction concepts which are related to the logic programming, and then we are going to talk about this Prolog Fundamentals. So as we know that according to our previous sessions, we come to know that knowledge representation is very, very important in order to make the AI agent to learn from it, and it can exhibit the intelligence. So even though if you could able to get some kind of knowledge, it will be very difficult to make an AI agent to learn it. So that's why what happens is, in between there should be some kind of transformation need to be done. Means the knowledge whatever we are acquiring by communicating with the human experts, that is not going to be directly helpful to make an AI agent to learn and to exhibit the intelligence. So in between certain kind of transformations we are going to perform. Such kind of transformations we are going to see in terms of logic in the today's session. So in simple words, we can say that the knowledge whatever we are gaining, that will be in the form of English. Okay, the knowledge what we are gaining is it will be in the form of English. So we are making use of some knowledge representation schemes or some knowledge representation techniques, and we are going to convert into the logic. We are going to convert into logic. Most probably it will be first order predicate logic. Okay, we can simply say first order logic or the first order predicate logic. So once we have this first order predicate logic, then we can convert this into the program. So in the earlier sessions, we have discussed about the knowledge representation in the English, and also we have seen how that English represented knowledge can be converted into the first order logic. Okay, so in today's session we are going to talk, today's session will be the first session where we are going to talk how these first order predicate logic statements are going to be converted into the programs. Why? Because first order predicate logic representations are not directly suitable or not directly make an AI agent to learn until and unless you convert this into the program. So to which program we need to convert, and what are the different types of programs that are already available in order to convert this FOL into the program, AI program that we are going to see in today's session. So that's why first we will talk a little bit about the logical programming and logic programming, and then after we will talk about the Prolog Fundamentals. Coming to the logic programming, we can say that logic programming is a technology that comes fairly close to embodying the declarative statements. So in simple words, we can say that logic programming is nothing but a programming which we use to declare some kind of statements. That's why we say that it is going to have some declarative statements. So the system should be constructed by expressing knowledge in the formal language. So we can say that the formal language, just now we discussed how this knowledge representation is translated from one state to another state. Okay, so we can say that this logic programming, it is going to make us to express the knowledge in the formal language. So the problem should be solved by running inference process on the knowledge. So what do you mean by this inference process? In the logic programming, we are going to work on these inferences. So what do you mean by inferences? Means trying to generate the new knowledge from the existing knowledge. We can say that these inferences can be done by the help of reasoning also. By the help of reasoning, that means that extracting more and more knowledge from the existing knowledge. Why? Because until and unless you have a sufficient quantity of knowledge, you cannot make an AI agent to learn everything and can exhibit the intelligence. So the exhibiting of intelligence by an AI agent is going to completely depend on the quantity and quality of the knowledge we are providing to it. So by the help of this inference process, we are going to extract more knowledge from the existing knowledge. So that's why we say that the AI problems are going to be solved by using one of the technique which is called as inference technique, or we can say an inference process. And coming to the point, what do you mean by this algorithm here? Why? Because every time we are going to stress on this particular point. Algorithm, we know that it is a step-by-step process which makes us to solve a particular problem. Okay, either it may be a general problem or it may be an artificial intelligence problem. So according to Robert Kowalski equation, he is representing the algorithm in a simple way, saying that algorithm is nothing but which is going to have the logic along with the control. So what do you mean by logic and what do you mean by control here? So we know that logic is nothing but which is going to have certain rules. Means logic is going to include with certain kinds of rules which we are going to apply in order to solve the problem. And the control is nothing but the control information. So as per the knowledge representation is concerned, this control is nothing but some control information which is going to tell or which is going to support us in order to select a particular rule at a particular state. Why? Because simply having a list of rules, it does not matter until and unless you use it in a proper way. So at what state, what kind of rule is really applicable, that is going to decide by the control information. And also sometimes what happens, there will be multiple rules which are suitable to a particular state. So in that case, which rule need to be selected and which rule need to be ignored, that is going to decide by this control information. So that's why according to this particular guy, he is telling that the algorithm is nothing but the logic and it is also going to have the control information. So logic programming, if we talk about logic programming and Prolog programs, we are talking about specific programs called as Prolog programs. So what do you mean by Prolog programs? Means Prolog is nothing but it is one kind of programming language. We can say actually it is not a programming language. We say it as a declarative language, or we can say it is a logical language. So logic programming. So in the case means if you want to represent the logic, then you should supposed to take the help of one of the knowledge language. So that knowledge, either it can be Prolog or it can be Lisp. Okay, it means among these two you can have a selection of anything. So here we are mainly concentrating on Prolog. We are not talking about the Lisp programming in this session. So we are saying that one of the language which we are using in order to implement this logic is nothing but here the Prolog. So how the Prolog programs are going to look like? Prolog programs are nothing but the set of definite classes written in the notation somewhat different from the standard first order logic. So in the life cycle of the knowledge, only we have seen that in the middle of the state there is a first order predicate logic. Means whatever the English representation knowledge is there, that representation we are going to convert into first order predicate logic. But the way how you are representing the first order predicate logic is not exactly same how you are going to write the Prolog programs. So Prolog program representation will be different, and it is going to make use of some of the things which is called as the uppercase letters for variables. So even we can say that the programming of Prolog is somewhat different when compared with other programming languages like C, C++, and Java. Okay, even Python is also going to be very much different when you compare with these Prolog programs. So we should supposed to know, means in order to have a good knowledge on this Prolog programming, we should supposed to learn from the basics. So we are trying to cover these basic concepts in this today's session. So we say that one of the fundamental concept we are going to talk here is Prolog is going to make use of the uppercase letters in order to represent the variables. At the same time, it is going to make use of the lowercase letters in order to represent the constants. Okay, as we know that variables and constants are the primary elements of writing a program, elements which is used to write a program. So that representation is also very, very important. So whenever it is mentioned, definitely you should not supposed to ignore it. Okay, so at the same time, comma separating conjuncts in a clause, and the clause is written backwards from what we are used to instead of. Okay, so what does it mean? Generally what happens if it is a first order predicate logic? Okay, if it is a first order predicate logic, we are going to write the statement in this way. Start with the left hand side and then we talk about the right hand side. So whatever the statements you have represented in this particular fashion, when it comes to the Prolog programming, it is going to be different. How it will be means whatever we have written in the right hand side in the first order predicate logic, it is going to be at the left hand side, and then the left hand side written statements will be at the okay, it will be in this way, means it is going to be left hand side statements will be here, means we are going to make a shuffle of it. Okay, for example, if I say this one a tends to b, then here when it comes to the Prolog programming, it is going to be like this. Okay, of course this is a very simple example I am giving, but we are going to study more examples which can show exactly the difference between the way of writing the statements in the knowledge in the representing the knowledge in the first order predicate logic and also in Prolog. Okay. So this is the one of the example which shows exactly the difference between the representation of the knowledge in first order predicate logic and the Prolog. So it is like this. So what does it mean? According to this predicate logic, it means that A and B, which implies to C. A and B, which implies to C. So we are not going to concentrate about the explanation, means why it is being represented like this, but only the thing I want to tell is the left hand side, means whatever we have represented this at the left hand side, and whatever you are represented in the right hand side, that is going to be entirely in the reverse way. Okay, so C is going to come at the left hand side, and you are going to have a colon, okay, this particular symbol, then it will be A comma B. So we need to know how these things are represented, how they have replaced, means we can say that the implies it has been represented with this particular symbol. Okay, at the same time, whatever this is the AND symbol as per the first order predicate logic. So this AND symbol we are going to represent with a comma. So in Prolog programming, if you mention comma, that means that it is a AND. Okay, right? So like this, lot of changes are going to be there when you do the comparison of this FOL and Prolog, that we will try to see one by one by taking some suitable examples. Okay, Prolog programs are executed through depth first backward chaining approach, means we are going to follow this particular approach. So what do you mean by this depth first search approach? Means whenever some kind of knowledge is represented in this particular knowledge, there will be a search, means a search activity is going to happen, right? That will takes place starting from the first line of the knowledge base, and it will go to the last line of the knowledge base. So if we say that it is a depth first search. Okay, for example, if you are trying to test a particular AI machine, so if you are questioning an AI machine, the AI machine is going to give the answer by making a search in the knowledge base up to the answer for an answer. Okay, so that answer identification will be done first by searching the first line of the knowledge base, then after the second line, then like that it is going to move to the last line of the knowledge base. So wherever it found that there is an appropriate answer, then that answer will be extracted from the knowledge base and it will be given as the answer to the question. Okay, so that's why we say that it is a best first search approach. And why we are calling it as backward chaining? Why we are calling it as backward chaining? So for this particular thing, we need to know one thing. Generally, most of the artificial intelligence programs, it will be in this particular state. That is, a problem will be given, and the intention of this problem is you need to move from a given state to the desired state. Most of the AI related problems will be in this way only. A particular state will be given and you will be asked to move to the desired state. So in between, what you have to do, you need to make use of the knowledge you have. If that knowledge is not sufficient, of course, we are going to communicate with the human experts and we will try to acquire more knowledge so that we can solve this problem very easily. Okay, so whenever it says that backward chaining, it does not mean that we are going to move from the initial state and towards the goal state. So what is happening? It is going to come in the reverse fashion. Reverse fashion means, first of all, the Prolog programming is going to start from the goal state. It will start from the goal state and it will try to move to the initial state. So what does it mean? Means when it is trying to move from the goal state to initial state, it is going to create some sub goals in between these. Means there will not be only one goal. Of course, when you are moving from the initial state to the goal state, you are going to see one goal point. But what happened? The Prolog is maintaining the backward chaining. So in this case, we can say that the backward chaining In the sense, it is going to start from the goal state and it will create some sub goals. It will generate some sub goals and it will keep on moving by solving each and every sub goal until and unless it reaches to the initial state, we can say. Okay, no, there is no issue here. We are going to study a lot of examples, and we are going to have a lot of explanation about this entire scenarios in the coming sessions. So there are some built-in predicates are there, which is going to have some side effects when they are executed. So now the question comes is, what do you mean by the side effects here? Okay, what happens? See, in the first order predicate logic, we are going to have some predicates. So whenever there are some built-in predicates, they are going to give some side effects when executed. So it means that if there is any dependency, you try to understand. If the predicates are independent to each other, even the application of those predicates or the order of applying those predicates will not makes any difference while solving your problem. But when it comes to the dependency, means if one predicate is having dependency with another predicate, then definitely the order matters here. So in that case, what happens if you implement the predicates, okay, as independent, then definitely it is going to give some side effects. Means sometimes what happens, in the previous state you may have already solved one particular goal, but when you come to the present state, again you have to go back to the previous state and you have to disturb the state which you have already solved. Okay, such kind of side effects you are going to see when you are going to implement these built-in predicates. Okay, but still there are some easiest methods through which we can overcome all these concepts anyhow. Okay, so these are going to include some input-output predicates and also nothing but some assets retract predicates for modifying the knowledge base. Okay, even these kind of things are going to see whenever you are trying to do the modifications in the knowledge base also. So only one simple point we can say here is, whenever a dependency between the predicates, when there is a dependency in the predicates, means when you are trying to change one predicate, then its dependent predicate is also going to change. Okay, so that thing we need to look into that. But of course, when it comes to the Prolog programming, we are going to rectify these kind of problems. Yeah. So logic programming is a programming pattern in which logical assertions are viewed as the programs. Okay, so whatever the logical statements are there, that logical statements we are going to convert into the programs. So as I mentioned just now, there are different kinds of logic programming systems are there. In that one is the Prolog. Okay, the another one we can say Lisp is another language programming system, logic programming system we can say. So if we talk more clearly or more specific, that a Prolog. So Prolog program consists of several logical assertions where each is a horn class. So what do you mean by this horn class? Means every positive literal is considered as a horn class. Means a class with at most one positive literal. Okay, one positive literal, then we can say that those are the horn class. So according to this here, we can say that P or Q, P implies Q, these are the positive literals. Why? Because at most one. It's not necessary that all should be the positive literals, but at most one should be the positive literal. Okay, so I cannot, even if I write like this, P or not Q, this is also going to be the horn class. Okay, but it should not be like this, not P or not Q. It will not be like this. At least there should be one positive literal in these examples. So we can say that the examples mentioned here, all those are the horn classes only. Let us talk more about this. See, here the horn class is a class that has at most one positive literal. So some other examples also we are taking. P is a positive literal. Of course, this is having not P, but still here we are having one positive literal here, and both here we are having the positive literals only. So that's why even these three things are also considered as the horn classes. The facts are represented in horn classes for two reasons. Okay, we are going to see how these horn classes are going to be used with an examples. But before that, let us try to have some more knowledge about these horn classes. So the facts, especially we talk about the facts, means the knowledge base is going to have some facts. Facts are nothing but the representation of the knowledge, we can say, representation of certain kind of information. Okay, so I can say that it is a fact. So what is a fact? Facts are represented on horn classes for two reasons. So what is the reasons? One is because of the uniform representation a simple and effective interpreter can write. It is very much possible. And also the logical of horn class is completely decidable. Decidable in the sense, right, whenever you apply the horn classes, definitely from that application you may get a conclusion. You may get a conclusion. So what this conclusion is, what is this decidable, and everything we are going to see with the examples. Okay, so the first two differences are the fact that Prolog programs are set as horn class and that we need to do the transformation. So what kind of transformation we should suppose to do? If the horn class contains no negative literal, then simply leave it. Means we are not going to disturb that horn class when there is no negative literal in that horn class. But if it is not the case, we need to perform the rewrite. We need to rewrite that horn class. How can we do it? Means negative literal, we should suppose to replace it with the implication. Okay, then automatically what happens? It is going to convert into the horn class. Okay. We will try to see some of the examples here. So this example clearly shows you, I cannot give guarantee that 100% you are going to understand this in the initial state. Why? Because we have just started the fundamentals of the Prolog programming here. But I will try to make it more clear. And if you found any disturbance in your understanding, definitely I believe that you are going to rectify it in the coming minutes. So what happened? The uppermost things we can say, these statements are the statements which we have represented in the logic. So what is the logic here? We represented the first order logic or first order predicate logic. So first order predicate logic, the example whatever we have taken is this one, A and B, right? That implies C. These kind of representations will be there. Okay, so what does it mean? What these representations are telling that for all x here, what is x here? X is a pet. It can be a dog, it can be a cat, it can be anything. So for all x, what happens? Pet x and small x implies apartment pet x. So we are going to decide, means with this statement we are going to decide whether the pet is the apartment pet or not. Okay, so in that case what we are doing, we are checking that whether this x is a pet or not, whether this x is small in size or not. Okay, then we have represented such kind of things by using this particular statement. For all x, pet of x and small of x, then we can say that it is a apartment pet. Similarly, the other statement you see, for all x, means for all x here, x can be an animal, pet animal, it can be any pet animal. So in this case, a pet animal can be either a cat or it can be a dog. Or it can be a dog. That's why what happened, instead of using and, we are using or here. So either it can be a cat, means x can be a cat or x can be a dog. Then in both cases, means if it is x is matching with any of these cases, then we can say that it is a pet animal. Okay, so similar to that one, for all x, podal x, that implies what? Dog x, and it is of a small size. Okay, next one is podal fluffy. So these are the statements which we have represented in the first order predicate logic. So we are trying to convert that into the Prolog code. So how it will be? Just now we mentioned that it will be in the reverse fashion. If this is the first order logic, then what happens when it comes to Prolog? It is going to be converted in this particular fashion, A comma B. So this is a Prolog code. Similar to that one, the entire thing you see in the apartment pet x is at the right hand side in this case. But what happened? It came to the left hand side in here. So when can we say that it is an apartment x? When it is a pet and it is of small size. Okay. Similarly, pet x. If it is a pet x, we are splitting this statement into several statements. Why? Because you see in this only one particular statement, we have mentioned that this pet x can be either cat or it can be either dog. So in order to reduce some complexity in representation, we have splitted that statement into two different statements. So what happens? If it is pet x, then it can be cat x. It can be a cat. If x is a pet animal, then it can be a cat. Similarly, if x is a dog, then it can be a pet. Means if x is a pet, then it can be a dog. Okay, at the same time, if it is dog, Okay, if it is dog, means if it is not cat, and if it is dog, then it will be poodle. If it is small, then it will be poodle. If it is poodle, then definitely it will be fluffy. Okay, so like this we can replace these statements. We can represent these logic representation statements into the Prolog representation statements. Okay, so this example is little bit complex, and we will try to overcome this complexity by taking some simple examples. Coming to the Prolog fundamentals. So first we had a little bit discussion about this logic programming, and we have also seen what is the differences that comes when you represent the knowledge in the first order logic and also in the Prolog. But let us move directly into the Prolog fundamentals, and we will see we will have a step-by-step procedure to understand what things will be there, means what are the most essential elements of this Prolog and how those elements can be used in order to convert these first order logic statements into Prolog statements. Okay, Prolog programming statements we can say. So when it comes to the fundamentals, Prolog is a completely declarative programming language. Okay, so in simple words also we can say that Prolog is a declarative language. Okay, so we can say that it is a type of programming language completely based on the mathematics and also the logic. Mathematics and logic, and it is closely likely to link it to the human reasoning. So what do you mean by human reasoning here? In the sense, the way how we explain the things. The way how we explain the things, it will be in that simple way. But only the thing is, it is going to include with some kind of mathematics, and it is also going to include with some kind of logic. Here, logic is nothing but certain kind of rules, we can say. Rules are terms and conditions like that. Okay, so that's why, as there is a logic also, okay, if you are simply declaring the statements, then we can say that Prolog is a declarative language. But along with these declarative statements, we are also going to see some kind of logic. So because of this point, we can say that Prolog is also a logical programming language. But only the thing is, it is going to completely based on the logic of first order predicates. So until and unless you have the first order predicate logic statements, you cannot able to convert that thing into the Prolog program. So that's why we say that the Prolog programs are completely depend on the logics of the first order predicates. Okay, so it is very useful in solving problems which involve the objects and the relationships. Objects and relations. Okay. Okay, we will see this, what these objects are and what these relations are now. Coming to the basic mechanisms and syntax. So what are the basic mechanisms is, one is called as the unification. Means there should be a unification need to be done. So unification in what sense? Means unification when you are preparing the knowledge base, and also the unification when you are asking the questions to the knowledge base. Means first what do we do? Initially we will try to prepare the knowledge base. Once the knowledge base is ready, then we will try to test that knowledge base. Means how far that knowledge base could able to give the answers to our questions. So once the knowledge base is ready, then we will start asking the questions. So whenever we start asking the questions, the answer of those questions are going to completely depend on the knowledge you have represented in the knowledge base. So during that time, during the time of extracting the answers to the questions, we are going to follow this unification approach. So what do you mean by this unification approach? Then we will try to see now. And next, it is a tree-based data structures. It is a tree-based data structure. So in the sense, we can say that most of the cases. So in just now we discussed that logic programming is going to implement depth first. It is going to implement depth first. Means each and everything you can make, each and every problem you can represent in the form of a tree-like structure. And it is going to include the automatic backtracking. Automatic backtracking in the sense, whenever a particular path, whenever we are the AI agent is moving in a particular path and came to know that that path will not make it to move towards a goal state, then automatically what happens, it will do the backtracking. Means it will come back. Okay, it will come back and it will try to move in the other path, we can say. Okay, so until and unless you have some examples, you cannot clearly understand what you mean by this unification, tree-based data structures and automatic backtracking. Okay, so we will try to cover this unification and this tree-based data structures in this session, and then we will try to see this automatic backtracking in the coming sessions. Okay, so we can say that state facts about means what this Prolog is going to have means it is going to state about the facts about the objects and also their relations. Just now we have seen. And it later on means once we state, nothing but here preparing the knowledge base, we can say. Means this statement, state facts about objects and their relations, is nothing but preparing of our knowledge base. Okay, so in the knowledge base, what we are going to see, we are going to talk about the various objects that involved in that particular domain. They are related to that particular domain, and also we are going to talk about the relation between the objects. Relation about the objects. Then once the knowledge base is ready, then we start asking the questions. Okay, so questions about what? Questions about the objects and their relations. Okay, so define rules about objects and their relations. So while preparing the rules, we are going to while preparing the knowledge base, we are going to define these rules about the objects and their relations also. Okay, we will try to take one simple example and we will see how this knowledge base will be there and how we are going to implement the unification and how we are going to start asking the questions to the knowledge base also. Okay, coming to the fact. Okay, means before seeing the examples for this database representation, means knowledge base representation and asking of questions, let us try to have some kind of a discussion on facts. So why? Because frequently we have used this particular word called as fact. So what do you mean by a fact here? Fact is nothing but an information given to us and provided to the Prolog database. We can in simple words, we can say that it is one kind of representation of the knowledge. So these information, so what this information is useful, how it is useful means these facts are going to make use by the AI agent. So we can say that this information can learn by the Prolog. Okay, means the Prolog program or the AI agent is going to learn or is going to gain the knowledge by making the use of these facts. Okay, so you try to understand fact is not a relation. Why? Because fact is different and relation is also different. So every fact consists of some relation and a single or some set of arguments. Okay, a fact is nothing but some kind of representation where we are going to see a relation and where you are going to have one or more set of arguments. Those arguments we are going to represent in the parentheses. You try to say, this is very simple example, we can say. So what is the example? So there is an English representation. What is that English representation means? First it is like this. Sita is the mother of Gita. So this is the English representation we are having. English represent. So what we have to do, we need to convert it into the logic form. So in this case, what happens? We are representing in this particular fashion. So mother, in the brackets, we are writing Sita, Gita. So just now we said that a fact is going to have a relation. So I can say that this entire thing is a fact. Okay, this entire thing is a fact. So what a fact is going to have, it is going to have the relation. That is, according to this example, it is mother, and it is going to have in the brackets, in the parentheses, either a single argument or more than one argument. So in this case, Sita and Gita are the two arguments related to this particular relation. So why we are calling it as a relation here, mother as a relation, means mother is the relation which is going to talk the association or the relationship between the two objects here. So what are the objects here? Sita and Gita are the objects. So what is the association? What is the relationship between these two objects? That is going to give by this relation. So that's why we say that in this complete fact representation, mother is the relationship name or relation name, and Sita and Gita are the arguments. Okay, means if you talk about the syntax, it will be in this particular fashion. Means relation, and in the bracket argument, it can have only one argument or it can have n number of arguments. Okay. There are some important points about this. What is that? The fact in Prolog always finish with a dot. This is important. You try to observe. Here also we have mentioned the dot symbol. So what this dot symbol will tell means it is the end of the fact. Okay. So here we are saying the dot represents that the fact is finished. It is the end of the fact. So what happens in the next line? There may be some other fact which is going to talk about some other arguments or some other objects. So the names of relations and arguments that refer to objects always written in the lowercase. This is important, means the relation name we have represented in the lowercase, and also the arguments also we have represented in the lowercase. So you should not supposed to take this mother or Sita or Geeta in the capital letters. Okay, not even single character also you should not take it in the capital letters. So these points we need to keep it in mind. We will take some examples and we will try to understand. So what is that? Is a friend of. Okay, is a friend of here. What happens here is a friend of will becomes a relation. So for what they are talking, this relation is talking about. It is talking about the association between the Ram and Rahim. So how we need to read it means Ram. So we need to read from the first argument first. We need to start from the first argument, and it is telling that Ram is a friend of Rahim. Okay, so in this fact we can say that there is one relation and two arguments. So how we are reading it as Ram is a friend of Rahim. When it comes to here, friendship, there is only one parameter. That's why we said that an argument can be a single argument in the relation, or it can have n number of arguments. So in this case, we are taking only one argument and saying that friendship. So how we need to read it means friendship is valuable. Friendship is valuable. Similarly, you take another example. So here the relation is has. What is has? So how we need to read it? KGF has gold. KGF has gold. Like that you should supposed to read. Okay. So when there are more than two arguments, so there are here what happened? There are three arguments. One is KGF gold and another one is Sita. So how we can read it? KGF gives gold, gives Sita. So we need to read in that particular way. Okay. So this is the another example how we are going to see, means we are going to learn from these examples how a relation and how the arguments will be represented in the fact. A set of facts. Okay, a set of facts also called as classes together with a set of classes make up a Prolog database. So this simple statement will say that, means if we consider all these statements, with these statements we can say that it is a knowledge base. So what happened? The knowledge base, how we have prepared this knowledge base, or we can say that it is a Prolog database. Prolog knowledge base or Prolog database. So how we are constructed this one means by taking the help of some set of facts. Okay, set of facts together with a set of rules. Of course, in this database we are having only facts. We never talked about any set of rules. Okay, so that set of rules we will try to see now. Okay, so this is a way how we can represent the relation and with some kind of arguments. Either it can be one argument or it can be more than one argument. So if we can say a fact is nothing but it's a combination of a relation in the brackets followed with some kind of arguments. In simple words, we can say that a fact is an information we provide to the Prolog database. So it is going to consist of the relation name and it is also going to have some kind of arguments. The facts in Prolog is always going to finish with a period symbol. So relations and argument names that refer to objects always written in the lowercase. And the arguments we should supposed to write it in the lowercase, and also the variables we need to write it in the uppercase. And the Prolog is going to run from top to bottom. Top to bottom in the sense when it performs the search for a particular answer in the knowledge base, it is going to start from the first line and it will move to the next line and it will keep on going to the until it reaches to the end line. End line here nothing but here the last line. So because of this one we are saying that the Prolog is going to follow the depth first procedure. As it is a depth first procedure and starting from the topmost line of the database, so we can say that it is also a top to bottom approach. It is a top to bottom approach. That's why we say that the Prolog will follow the top to bottom approach while extracting the answers for a given question. So how coming to the questions, see means just now we seen that how the knowledge representation can be done, means how the knowledge bases can be prepared, and we have seen one example how this knowledge base will be. So next, once we have the knowledge base, then our next duty is we need to test that knowledge base, means whether we had enough quantity and quality of knowledge in the knowledge base or not. So how can we come to know, means when you keep on asking the questions, if your database could able to give the answers to that one, then we can say that we have prepared a well knowledge base, well efficient knowledge base, we can say. So we'll try to understand how this series of questions can be asked. Okay, so we can say that a series of questions can be asked about a set of facts. So what facts we have mentioned in the knowledge base, to that particular facts only you should suppose to ask the questions. The answer to these questions can be either a true or false. Means we can, in simple words, we can say that the output of our questions will be there is a possibility of only one answer. It can be either true or it can be either false. Okay, what does it mean? Means whatever the question you are asking, if that question is matching with the knowledge base, then answer you will get is true. Okay, if the question you are asking and which is not matching with the knowledge base, means the knowledge represented in the knowledge base, then obviously the answer for that one will be false. But before giving the results either true or other false, okay, because of this true and false, we say that the answer will be the Boolean value, either true or false. But before giving the answers of true and false, we need to perform the unification. The first one we have discussed, unification, tree representation. Okay, the 2 points we have seen. The third point is automatic backtracking, that we are not going to cover in this session. So unification need to be performed. Means after implementing the unification process, or after following the unification process only, the Prolog is going to give the answer for our question either true or false. Okay, we will try to see how this unification process will be happened. Okay, there should be same number of arguments. There should be same number of arguments. So what does it mean? Means if your question is having 2 arguments, then definitely to that related one in the knowledge base also there should be some fact with 2 arguments. Okay, then only you are going to get a true answer. Otherwise there will be a false answer to you. That means the answer will be false. And relation name should be same. Okay, for example, think that in the knowledge base you have represented a relationship as ABC. While asking the question also, you should suppose to have your relation name as ABC only. Then only it could able to give either true or false answer. But whenever these kind of things are not matching, then we can say that we cannot expect a true answer here. Means while asking the questions, you try to understand. First it is telling that whenever you ask questions to the Prolog database, your answer may be either true or false. But before giving the answer true or false, it is going to perform internally the unification. So while doing the unification, it is going to check for these things. What is that? It is going to check whether you are having the same number of arguments or not, and whether the asked question and the knowledge base is having the same relation name or not. Okay, and one of the argument must be same. That is also important. Means not only just matching the relation names will not give the answers for us. So even there should be at least one matching argument should be there. Okay, so we will try to see one example and then it will be very much clear for us. Coming to the unification. So we talk more about this unification here. What is that? Relation name in the question must be equal. Equal in the sense it is same to the fact. It is same to the fact. Means the relation name mentioned in the question should exactly match with the relation mentioned in the knowledge base. And the number of arguments also must be equal. For example, in my question, if the arguments are A comma B, so in the knowledge base also there should be a relation with argument A comma B only. Means in that case what happened, the relation name should match and also the arguments also need to match. So names of arguments referring to objects must be equal in the question and in the database. We will try to see the example, then it will be very much clear. So this is our database. What is that? In this database we are represented 4 facts. Okay, so one fact we are talking about John. John has a book, Sarah has a paper, silver is valuable. Okay, John has computer. So this is the knowledge base whatever we have prepared, and we need to test this knowledge base. So how can we make the test? By asking the questions. So this is nothing but the question. Okay, so what this question is talking about, what does Sarah has? This is a question. Means I want to ask this question to the knowledge base and I want to know what that Sarah is having. So how I have represented this is a Prolog way of representing the questions. So has. So what the first statement of unification is telling, the relation name in your question should match with the relation names in the database. Okay, so what happened in the relation name we have mentioned as. So here what happened in the database, we are having 3 facts which are matching with has, and the number of arguments in your question should match with the number of arguments in the database. So what happened, this all the 3 has is having 2 arguments, so here also there are 2 arguments. And what is the third point? At least one argument should match. At least one argument should match. So here what is the first argument we have taken? Sarah. Means the relation name which is having has and the relation which is having the first argument as Sarah, to that particular fact this question is asking about. So what happened, it will comes to this one. Okay, so immediately means we are asking a question that what is that? Sarah has what? It is T here, what? So this T is going to talk about the paper. It is going to talk about the paper. So immediately what happens? The answer you are going to get is paper here. Means what? What does Sarah has? Sarah has the paper. Okay, but you try to understand the answer will be either true or false. So in that case what happens? If it is T, then it will give the true. For example, if I make the question like this, question has Sarah, comma, paper. So again in this case also unification is going to happen. So in the unification what happens? The relation names are going to match, the number of arguments are also going to match, and the arguments are also going to match. Paper and Sarah and paper. So the answer for this one will be true, because it is matching with the database, fact present in the database. Like that it will be. So you can have some kind of exercises in this particular thing. So what is the exercise I am giving here is try whether all the facts are matching with all the conditions of unification. Okay, remember that all the conditions must satisfy. All the conditions must satisfy. This you need to check it out, and also you need to try whether all the facts are matching with all the conditions of the unification. And also you need to make one thing, remember. What is that? Keep that semicolon to get the other possible solutions if exist. So what happens here? You see, sometimes what happens, your question may matches with the 2 answers of the knowledge base. So whenever you press the enter button, you are going to get the first answer, but there is a chance of the other answer also. Means possible outcomes are more than 1. So if you want to see the second possible outcome, then you should suppose to keep a semicolon at the end. Okay, then it is going to give the next answer to you. So what you have to do is you need to implement, means you need to check whether the facts are matching with all the conditions of unification or not. If there is only one possibility of getting the answer, then this kind of asking questions is okay. Means after getting this paper, simply if you press the semicolon, if you keep the semicolon, right, if there is any other relation in the database is matching, then you are going to get the answer for that one also. Okay, means if you are the possibility of getting one answer is only getting only one answer, means you can simply keep a full stop, or otherwise after getting the answer you can simply quit, right? If you think that there is another possible answer, then immediately after getting the first answer you simply keep the semicolon. Okay, so the next answer will come, next possible answer will come. So how many number of possible outcomes are there? Those number of possible outcomes you can see, right, just by keeping semicolons at the end of the each and every answer. Coming to the conjunction of objectives. So try to consider this database. Progenitor of Sita, Kama, Gita, and so these are some kind of we can say some family members we can say. So what is this family members are talking about? Sita is the progenitor of Ram. So how we will try to see how this, anyhow we just now seen how unification will be implemented. Now we will try to see how the tree representations can be done. So this is a database or knowledge base we are going to take, and we will see how these can be represented in the form of a tree. Okay, so what happens here? Sita is the progenitor of Ram. So in this case we can represent the thing like this. It is Ram representing the eclipse, and we say that it is Sita. It is also in the eclipse. So how it will be? It will be represented in this way. Okay, means Sita is the progenitor of Ram. Similar to that one, the second fact is telling that Rahim is also the progenitor of Ram. So in this case, what happens here? We write Rahim, right? And you make a connection here. Next, what it is telling, Rahim is the progenitor of Shravani. Okay, so Rahim is the progenitor of Shravani. So there should be another one, Shravani. You represent like this. Next again, Ram is the progenitor of Anand. So Ram is a progenitor of Anand. Ram is the progenitor. Progenitor of whom? Progenitor of Anand. Next, Ram is the progenitor of Rajesh. So how can we represent? Ram is the progenitor even to Rajesh also. Okay, so it will be represented like this. And next, the last statement what it is telling, Rajesh is the progenitor of Bhavana. So where is Rajesh? Rajesh is here. So Rajesh is the progenitor of Bhavana. Rajesh is the progenitor of Bhavana. So like this, whenever a certain kind of database is given to you, and if they are related to each other, then you can make a tree-like representation of your knowledge base in this particular fashion. Okay. Okay, so you can make some kind of practice by using this database also. So what is that? The hint given to you is you need to implement the unification. That is, the relation name should match. That is the first rule of the unification. And the second rule is the number of arguments should match. That is the second one. And the third one is at least one argument should match. Argument should match. So these are the three conditions for the unification. So while solving these particular answers, you can implement this unification process and you can extract the answers for this. What is that? Progenitor Thomas, Jos. Okay, so you try to understand. So what happens? Progenitor, this argument is going to match with the facts in the database. But what about even the number of arguments are also going to match. But what happens is these arguments are exactly not same in the knowledge base. So what happened? The answer for this one will be false. As there is a comma in the sense, okay, it is and. So it will be like this. And progenitor Thomas, Isabel. So here these things are also not there. Means these arguments we have not mentioned in the database. So for this one also we are going to get the answer as false. So false and false is going to give again false. Means the answer for this statement will be false. Okay, similar to that for this one also it is going to get false only. Why? Because even though the relation name is matching, the number of arguments are matching, but the arguments are not exactly same. Means the arguments what you are asking from the question is not the same arguments which I have represented in the knowledge base. Okay, so you can make the changes like this. In place of Clara, if I write Sita, okay, in place of Jones, if I say Ram, what happened? This statement is going to be true. Okay, this statement answer is going to be true. And when it comes to this one, I will replace this one. Ram, and this one is Anand. Ram and Anand. So what happens? It is going to match with this fact. So this statement is also going to be true. We mentioned and in between. Comma is in sense and. So what happens? It will become true and true. The true and true answer is going to give true for us. Okay, so like this the Prolog database is going to work, and also you can come to know how this row questions can be asked, how can you test the knowledge base. Okay, so this is the reference what I have used in order to prepare this particular concept. Hope you understood the fundamental concepts of the Prolog and the little bit introduction we have given about this logic for programming also. Okay, so we will try to see more fundamental concepts about the Prolog in the coming session. Okay, till then, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.